question. So our discussion tonight will be mainly focused on Bluetooth Low Energy, what it is, and what are the areas that is growing, is getting lots of interest in, and what is the next step? What is the next version of Bluetooth? Bluetooth, we have two terms I can show you in my slide. First of all, who I am. My name is Vincent. I'm based in Seattle, and I'm the technical PM in Bluetooth SIG. And Bluetooth SIG is a nonprofit organization. It's a special interest group. It's a member-owned organization. We have 24,000 members, and we don't own the spec. We don't own any of the Bluetooth property. We don't own running. It's all the property of the members. And the next, Bluetooth, we have core stacks, we have technical stacks, and we have different working groups. Everything's member owned. And this is the topics we're going to cover tonight. So when we talk about IoT connectivity, wireless connectivity, what options do you have? What can you use? We have Wi-Fi, we have Wi-Fi Direct, we have ZigBee, different flavors of these. We also have different flavors of Bluetooth. The pros and cons of each and every option we have. And then we talk about the Bluetooth 4.1, which we released last November. And that's the latest and greatest Bluetooth stack. What's new in that? What new features added to this 4.1 release? And then what platforms are ready for this Bluetooth 4.1? We'll introduce you some of what is available, what platforms are available, and what features are available on each and every one of the platforms. And the new trends of use cases. Where do people use Bluetooth? How they use it? And then we'll be talking about some best practices when you use Bluetooth Low Energy, and some known issues. Some of the issues are from technical limitations. Some of the issues are from the implementation of Bluetooth. And then some interesting topics, including security. How secure is the Bluetooth connection? And the privacy. People are getting more and more concerned or interested in how to protect their privacy in wireless connection. And interoperability. Devices using different transmit talk to each other. That's a very interesting area. So, working for Bluetooth's sake, almost every week I got phone calls from people all around the world. So I call it, I got an idea type of phone call. People middle of Texas tell me, listen, I have an idea. But I can't tell you what it is. You need to sign an EA. And then I want to connect to something. This is getting more and more popular nowadays. I want to connect to my coffee mug. I want to connect to my toothbrush. I want to connect to my tablet. IoT is really, they want to connect to everything. It's connectivity is a big thing now. So most of the questions to me are about the wireless connectivity. How can I connect to my device? How can I connect to my fleet wirelessly? What is the best option, or what is the best way, or the easiest way to connect to my toaster, right? So here's a list. I know Joe DeCour from CSR came here this May. He gave a presentation about Bluetooth and Internet, the web connectivity of Bluetooth. There you go. And this is pretty much the same. He showed this table, and I have the same thing here. What is available? And we have different models. Bluetooth Classic, Bluetooth Low Energy, Wi-Fi, Wi-Fi Direct, and ZigBee are the major connectivity transmit. Now it's available. So there's, everybody, if you work in the technical area, there's no good technology or bad technology. It's only the right technology, right? It's just, from different factors. One of the important factors when you're choosing the connectivity method or technology is what data you want to transmit over, right? How frequent you want to transmit the data over. So we have audio, video, and voice, not the streaming data, right? Those are for Bluetooth Classic. So Bluetooth Classic, Wi-Fi Direct, they have very good support for that because those type of applications require a certain amount of bandwidth, right? So when I talk about Bluetooth Classic, I have a Bluetooth 1.1, or Bluetooth 2.0, Bluetooth 3.0, Bluetooth high speed, anything before Bluetooth 4.0, or Bluetooth low energy, or Bluetooth smart. That is called Bluetooth Classic. And after that, that's Bluetooth low energy. And low energy is basically for the IoT things, the sensors, the state of a device, or the state of the thing. Right? Low energy, you can see that. So we have another technology called JP. They have different flavors, and now they have J-Wave. They have low energy support as well. I can explain in detail later on which one has what functionality or features. So one of the most asked questions from the media, from the press, almost every single time I have a media interview, and they'll ask this question: hey, can you compare Wi-Fi with Bluetooth? Can you compare Wi-Fi direct with Bluetooth? Which one's better? Which one's the pros and cons? Again, there's you can't say, hey, Bluetooth low energy or Wi-Fi direct is better than the other. It's just which one fits your requirement, fits your use case the best. By the way, if you have any questions, feel free to stop me. Hey, listen, go ahead.
Is that able to switch back and forth between classic and regular so that it's basically multiple passes?
The question is, if you have 4.1, can you switch back to classic, right? Can you use 4.1 to talk to a classic device? No. The answer is, if you have a single Bluetooth low energy chip, it cannot talk to a Bluetooth classic chip. But nowadays, most of the phones, right, they have something called a combo chip. The combo chip has both low energy and smart and classic. Right, so your phone can talk to either the classic and the low energy. Correct. Well,
can you elaborate the Bluetooth low energy power with CCP in terms of network connectivity and in terms of how really long
I'm writing a book about that.
Because CCP is basically used for what I know very low energy
Better than that. Yeah. So we want to say, hey, you can do this, can you do this? And well, come back to me by the end of the presentation if there's any question I haven't answered, we can talk. So back to Bluetooth. So this is the shipment for Bluetooth chips, including the combo and Bluetooth BLE and Bluetooth classic chips this year. 31 billion Bluetooth chips shipped this year. Most of them are the handset, the cell phones. So that's why Bluetooth is very successful, because it's available in everybody's hand, right? And so Bluetooth Classic was really successful mainly because there's one user app and there's one killer app. The hands-free, the Bluetooth headset, right? So 96, we had this number, 96% of the consumer, when being asked about Bluetooth, they say, hey, I know Bluetooth, it's a headset. That's a killer app for Bluetooth Classic. So we're looking for a killer app for Bluetooth Smart. What would be the killer app for Bluetooth Smart? Should that be Beacon? Should that be Mesh? Or something else? So the big improvement of Bluetooth Smart, Bluetooth Low Energy over Bluetooth Classic is it's more flexible. You can define your own profile. For in Bluetooth Classic, we have adopted dozens of adopted profiles. If you want to develop an application, you have to use this profile. Profile is like a protocol, a data structure. You have to follow that. You have to implement that. But in Bluetooth Smart, you can define your own data structure. You can define your own interfaces. It's more interchangeable. You can talk to, say, an Android phone. You can talk to an iOS phone over Bluetooth. It's low power. The reason Bluetooth Low Energy is low power or is low energy are majorly two reasons. One, it's quite simple. It's very simple. It's a very simple protocol. And it's split most of the time. Right? If I don't have data to send over to you, I would just split. Right? When there's anything, the majority of the time of the Bluetooth chip will be spent on splitting. So that's why it's power efficient. So there's a, so how many people are familiar with GATT? Yeah, so let me explain that to you what GATT is. So this is, so Bluetooth, you have the physical, you have the chip, right? You have the chip and you have a stack, software stack, or sometimes we call it the firmware running on top of it. So this is the physical. And then we have a link layer. And then here's the interface. This part is called the controller. And this is the host. And in Bluetooth Smart, or Bluetooth Low Energy, we have, this is called L2 cap, big layer control. We talked over this is HCI. It's an interface between the host and the controller. And then on top of this is called attribute protocol. So basically all the data are attributes. And then it's a very simple protocol called generic attribute protocol. So it opens all the data from all the layers below as interfaces, as services. Oh, all right. So everything from Bluetooth Low Energy are services. Right? So you can define your own services. So we call it a custom profile. Right? And You can, and also we have some predefined profiles. We call it adaptive profiles. And thank you. It's like we have hardware monitor profiles. We have the time profiles. Commonly used services, we define those as the adaptive profile. And if you see, hey, I have a special use case that none of the adaptive profiles could cover that, I can define my own profile, aka my own services, my own data structure. So this is the flexibility of Bluetooth Smart. And one of the important factors of the successful for Bluetooth Smart is majority support from mobile phones. You develop for whatever the user is having, right? You say, hey, I have a proprietary profile that is better than all of the existing connectivity profiles or protocols. But people we don't have that on most of the phones. Does iOS support it? Android support it? Does Windows support it? So all those, iOS plus Android, Windows and BlackBerry covers 97, 98% of the headset market. Right? So almost every single phone now supports Bluetooth Low Energy. Bluetooth 4.1, we released 4.1 last November. There's a very important feature in 4.1, which lays the foundation for IoT application using Bluetooth. We call it dual. What that means is, say we have so using Bluetooth, you have two devices talk to each other. And this one is central. And this one is peripheral. Right, the peripheral is the one, or we call it, this is a slave. This is the master. Right? Before Bluetooth 4.1, one device can only be one row. It can be either central or peripheral, but not at the same time. In Bluetooth 4.1, you can be central and peripheral at the same time. Why do we need to have this feature? Because once this is connected, I have another node, and I have more node. Right?
Question. Is it two roles at the same time, or can it switch quickly from one role to another?
Good question. Yeah. This question was, is it two roles at the same time, or you switch between two roles? Right? Before 4.1, it's used Bluetooth 4.0. You can switch between two roles, but you cannot have two roles at the same time. In 4.1, you have two roles at the same time. And the reason we want it is we want to have a mesh network. Right? This one will be the master for this, and could be the slave for this. We want to have mesh network. Go ahead. Yep, someone's doing it. I can explain in detail later on. So this is a very important factor, very important feature. So part of my job is helping people developing Bluetooth applications. So one thing people always, it takes people some time to understand this. We have this is called GAP, generic attribute protocol, and we have something of GAP, generic access protocol. Access protocol is about whether how can you discover that node? How can you set up connection to that node? How can you advertise your services? So this GAP. GAP is all about data. GAP is all about connection. Right? So, yes. So this one, I said that in 4.1 it could be both central and peripheral. And we have another term called server and client. A Bluetooth server and Bluetooth client. Keep in mind, server, client, and peripheral, central, slave master, those are interchangeable. What that means is central doesn't always have to be the server. Central could be a client. Think about it. You have a watch, you have a cell phone, what's providing data? So this is a very important concept. Okay. Second important feature in 4.1, secure connection. There are always people coming to me saying, hey, Vincent, I want to show you a picture on the internet that someone hacked the Bluetooth connection, and here's, a hacker hacked the latest, products from company ABC XYZ. So is Bluetooth connection secure enough? I think the question is, the answer is twofold. Is Bluetooth protocol or Bluetooth technology secure enough? Or the question is this product secure enough? Or said, is the implementation of the technology secure enough? So we have this term called pairing and bundling in Bluetooth. One more thing I want to mention that Bluetooth Classic and Bluetooth Low Energy, majority of the technology are different. They are sharing the same band, 2.4 gigahertz band, and they are sharing some of the components on the physical part, on the physical layer. That's pretty much all. So a lot of concepts are different. One, for example, pairing and bundling. In Bluetooth Classic, you use Bluetooth headphone. You have to pair it before you can use it, right? You have to, you open the box, you get a new headphone, you have to pair it, you type in the 6 digits or 4 digits. You pair it, and then you can use it. But in Bluetooth Low Energy, you don't have to pair it. It's so simple that it can just, advertise and set up the connection. You don't have to pair it. But still, in BLE, we have this feature called pairing and bundling. Those are for security. You want to encrypt the connection. You want to make sure that connection is secure enough so you pair. Questions, comments? Yeah.
What happens if somebody is national and someone has
Tell me more about how can you get into my pairing connection.
Are these basically two virtual machines running separately so that you can't get across? Or you get a sharing memory, you can get it.
So the communication channel between you and me the channel is encrypted. we're using the public key and private key to encrypt. Yeah, you can get the packet. You can get, yeah, you can have a supercomputer. You spend a year, you can decrypt it. Yeah. So there's a security, if you work on security, FIX, this is the Federal Information Protocol Standard. It's the, so FIX requires that you have, what is that called? It's 256 bits encryption. If you have 256 bits encryption, that means, well, we call it, you need the FIX encryption standard, right? All the encryption, if you have a super powered computer, you can decrypt it. Yeah. You can. That's doable. That's possible. But that's not only, that's pretty much for all the wireless communication, or even wireless communication. Because we have, the SSL, you can decrypt it, right? You can have, all the other, as long as, you have enough computing power, you can always do it. That's a different topic. Right? Well, that gentleman has a question, yeah.
So just to be clear, you're not using exactly the terminology that's standard. So is every Bluetooth node potentially a router?
Not sure I understand the question. In mesh network, could be a router.
Okay.
Well, if you talk, well, I can explain more, but each one at least should have the routing capability, right? So I will have a slide to discuss, to show you more about the mesh network and how to implement this, or what does it make it. Yeah. Privacy. People getting more and more concerned, or at least interested in privacy issue. So why do we need to talk about privacy when we talk about Bluetooth? So I said every single phone has Bluetooth, right? You turn Bluetooth on, you can either broadcast and advertise, hey, I have a service, or you can listen to someone else's advertisement, right? So we have new use cases, beacons, right? Beacons and broadcast, you can receive those advertisements. So beacons will be deployed majorly in retail stores, shopping malls, and those beacons can collect your information. I know you showed up at Macy's last night, and I know you checked into that hotel last month. People don't want, people don't feel comfortable. So we have this feature called privacy. What that is you have every single Bluetooth device has its own address, right? Its own address, its own private address. On top of that address, so we identify the device by its unique address. On top of that unique address, we create a layer that gives you a fake address is a rotating address, right? So every single time you look at that device, you will see a different address, or you will see a different, by that address, you see it's a different device. So that can provide, can protect your privacy. One more feature in 4.4 is the link layer connection. You don't have to, so in this slide I erased, you don't have to go through the attribute layer gap. You can connect. There's a channel. We're providing people a direct channel to link layer to talk to a different device. You don't have to go through separate layers. It's just this optional feature that gives you a better performance. So it's coming December, we're going to have a new release of Bluetooth. So we'll have more features. We'll make it more secure. We have better bandwidth. So another, go ahead.
Sorry, going back to the privacy feature. So you said you've got physical address and you've got rotating
Right.
virtual address on top of it. It can go on top of a rotating address, is that what you said?
Yes.
So how many possible rotations?
It's a random address.
Okay. Okay, so it is random. And is there any possibility of collision between two devices that are talking to each other?
Say that again. Is there any?
So address collisions between two devices that are talking to each other developing a random address?
Those are the 256-bit address, and the testers are pretty small. And plus, we're talking about personal area network. Bluetooth can only work 150 meters, right? Even the collision is the chance of collision is pretty small. Okay, so that's another topic. Hey, how far can you reach using Bluetooth low energy, right? It can go. It depends on this is a implementation specific question. Like this chip can go very long range, right? But long range means higher power consumption. Right? You want to save power to be power efficient, you have to lower it, you want to reduce the range. Another question is, what is the bandwidth for? You said Bluetooth low energy is for state. What is bandwidth for Bluetooth low energy? Theoretically, in Bluetooth low energy, it's 1 mega per bps per beat per second. That's the theoretical number. But in reality, most of the solutions or manufacturers can get from 10K to 20K bps. That's low energy, but we are working on the next version of release. Hopefully, this could be improved a lot. So, Internet of Things nowadays is always, hey, I can connect to my coffee mug. I can connect to my toothbrush. I can connect to my light bulb using my phone, right? So almost a lot of IoT applications have the mobile phone involved. So mobile platform is quite important for IoT applications. So here are the feature set for different platforms. iOS is the first platform that support the Bluetooth Low Energy. In the latest version, iOS 8, it started supporting Bluetooth Low Energy since it's iOS 4 or iPhone 4S. Now iOS latest is iOS 8. It combines with Bluetooth 4.0 and it has native iBeacon support. Some people heard of iBeacon here? Yeah, okay, thank you. So iBeacon is our beacon, Bluetooth beacon, originally from invented from by Apple. Anyone from Apple? No? You are? Okay. So this is a very useful scenario, but it could pretty much open a huge ecosystem. There's a lot of possibilities of iBeacons, not only for retail stores or parts. And another very good feature on iOS I like very much is molecule connectivity. Anyone heard of it? So people are talking about mesh network. iOS has already implemented mesh network. It's available in iOS. So another good feature from iOS is ANCS, Apple Notification Center Service. So the app engineers, they designed this very well. I always tell people this could be used as a textbook in the Bluetooth application design. You can find the AMCS design stack on their developer network. It tells you how to design a Bluetooth application, how to design the services, what is the hierarchical structure of the services, and why we do this, and what are the, we have different data types, how do we use the data types, what to expose to the partners or developers. So AMCS is a foundation for Beacon. I can explain to you why when I talk about Beacon. And in iOS 8, there's a service called Apple Media Service. So this service is using Bluetooth for smart home media control. You can use your remote control to control TV, audio, or it's part of the HomeKit is based on this. A lot of the feature from HomeKit is based on the media service using Bluetooth engine. And there's a very cool feature called handoff in iOS 8. Probably, some people have not aware of this. Handoff is a feature that, say you do some work on your MacBook, and then you go home and switch to your iPad or different iOS devices, and all the state on the previous device will be automatically synced over Bluetooth to another device. All the features are using Bluetooth Low Energy. Anybody's on Google? Okay, and Tom. So Android, latest Android version, Lollipop, they support 4.1. One good feature that Lollipop or the Bluetooth stack in Lollipop. So a little bit of history of Bluetooth stack on Android. So Android, before Android 4.2, Google did not put Bluetooth support in it, and this company, Broadcom, they decided to open source a Bluetooth stack, and then Google decided to, incorporate that stack into Android. But in the first release, 4.2 release, they only put part of the feature of that Broadcom stack into 4.2. And 4.3 is still problematic. We got a lot of feedback, a lot of complaint about the implementation of it. There are some good features about Bluetooth on Android. So on Android, you can have the raw data from advertisement, which is not available from iOS. I'd say you have the deep broadcasting, this data, and on iOS you cannot get the PDU of that data, of that packet. But on Android you can.
What is a PDU?
The data part of the packet, other than header, I don't know. One of the known issues on Bluetooth mobile application is, so Android there's in their latest Lollipop they fixed many issues, but still it's problematic. A lot of the basic operations are not stable. But workarounds there are other stacks available. So it depends on who you are. If you own the device, right, you can have different Bluetooth stacks on Android. You can switch out the original Unix stack and have your own stack. Also, before this, the Broadcom stack, there's Android use a stack called BlueZ. BlueZ is the Linux-based stack, and nowadays BlueZ ported for they ported the BlueZ to Android. It's more reliable than the Android native one, so a lot of companies are switching back to BlueZ. There are two initiatives. Sorry, I missed the dash here. Two initiatives in Google, which are very interesting. One is called the physical web. So what that is so nowadays we have IoT applications. I have an app on my phone or my laptop. I have another app for my toothbrush. I probably will have a different app for my coffee mug, right? But from the user's perspective, a user cannot open an app for this and then close it and open another one. It's not the user experience. There's got to be a control panel for the end user to control all the devices, right? This is a control panel, right? So we're using this term physical web. It's using the Chrome browser to talk to the browser. The browser will be having a Bluetooth stack, which will be talking to the Bluetooth device, which is a very smart idea. And this one is question.
Is each individual device can be talking to each other?
No. The question was, could devices talk to each other? Yes. I call it the first stage. The first stage of IoT is always to connect to the thing. If you use my phone, I can connect to the coffee mug. It's not really a smart or we got a smart home because I can connect to my fridge and connect to my toaster. It's not smart enough. The real smart application is, say, the toaster can talk to, or the toaster might not be a good example. The curtain, my curtain, can talk to the thermostat, right? Without the human interaction or without any command or control. Devices can talk to each other. Open source. A lot of effort from the open source community for Bluetooth. Number one is one very good Bluetooth stack called BlueZ. It's owned by 3 developers in Europe. It's very mature. They do tons of work on that as the latest. BlueZ qualified for 4.1, Bluetooth 4.1 core stack. And Arduino, we have, if you go to Amazon and search Arduino Bluetooth, there are tons of Bluetooth shield that put it on top of Arduino. Actually, I have something to show you. There's a company based in San Francisco. They created this small device called Beam. It's a very cool device. It's a smart guy created this very handy, useful device for your protocol, for your prototype, or your MVP, or want to verify or want to prove something. Cool concept. The company is called Punch Through. The product is called Beam. So what it is, it's just integrate the Bluetooth chip with the Arduino. It's a single board. You can see the form factor is very small, and it has the accelerometer and I think it's gyrometer on it. Yesterday on NPR, there was a story about the company on the East Coast created an application. They call it Dorsey. So what the application is, they put a small chip on your boots, So some once or do something, and some twice, or when you're phone and you can run out of that day or something like that. So you can use this to implement this application like in 1 day or 2. And this is Arduino with Bluetooth 0. Yeah, the punch looping. I created a package called Application Accelerator. It's an open source Bluetooth app. I implemented it on 3 different platforms: iOS, Android, and Windows Phone. I put it on GitHub. So if you go to GitHub and search App Accelerator, you can find it. We talked about Bluetooth. Okay, I have an idea. So some of the cool ideas nowadays using Bluetooth speaker. Beacons, smart homes, mesh, and wearable. Those are the very popular or very interesting areas that people are working on. Okay, this is our marketing slide. So they did a research on Indiegogo and Kickstarter that 76% of the hardware project on Indiegogo are using Bluetooth Smart, and 9 out of 10 are on Kickstarter using Bluetooth Smart. Okay. Opportunities. People in Bay Area like to hear opportunities. So this is the picture I made over there. The controller. There's the host, right? We have physical link player. We see that out that. So now this, if you develop a hardware, you have a co-device, consumer electronics. You need both the EE electronic engineer and software engineer, firmware engineer. So this is mainly the firmware side. What are the opportunities on the firmware side? So one of them is on the app and ATT layer, you can have a service to expose all those data to the wider network, to internet. So it's something called Internet Gateway, because Bluetooth only, like I mentioned, Bluetooth device only cover 100 to 150 meters. If people are working on Bluetooth gateways to connect the Bluetooth device with the internet service. Another interesting area is on security. So with this device, that gentleman asked me, hey, can device and device connect to each other, right? How can this device talk to, say, it's another device? How can the 2 devices talk to each other, right? We know we can use Bluetooth, but how can they pair to each other? We want to talk securely, right? None of them have input or output capability. You can't type in any of the numbers. How can they pair? So we have a working group, music pairing working group. Without any I/O capability, how can the 2 devices pair each other or exchange or set up the secure connection? Right. Another effort from our members is how do we improve the networks? How do you use BLE Bluetooth energy to transfer video, audio, and voice, like audio over LE? And those are the opportunities on the stack. Beacon. Beacon is the simplest Bluetooth application. It's very simple. It's just advertising. We have 4 different types of advertising just using the simplest. Unconnectable. It is advertising. You cannot connect to it. You cannot send connection requests because it cannot respond. It's indirect advertising. It doesn't know who's seeing it. So is very simple application. But the beacon application or iBeacons or beacon over Android, they all requires platform support, right? So you have this device in the store, so people have this beacon as a backpack. They put it on, boxes. They put it on boxes as a backpack. So if you have your phone, you're in the range of the beacon. You can receive information, right? So the beacon is not giving you all the detailed information. So the beacons only give you 3 numbers. All the information beacons broadcasting to you are the 3 numbers: the major ID, the minor ID, and a device ID. All the 3 IDs. You have to connect to the cloud to get more information. It's just identify this is a beacon. This is a unique device, right? And there's an application, I call it museum application. Like you go to a museum, you are in front of this painting. You open your app and there's information. There's some information about this painting, and you move to the next painting, and then you check, right? Another page information about that. Beacon is not like that. That's not beacon. The most important part of the beacon is why I said it's platform support. Is you have to open the app, right? Once you register with that beacon or with or we call it you opt in, you give them permission to broadcast to you, right? And then every time you walk into the shopping mall or the store, the information or the message will pop up automatically. You don't have to run the application either in the foreground or in the background now. You have to launch it. It will automatically, the system, the operating system, will automatically launch the application for you, for that, right? So, other than using beacon in the retail stores, you will have that in the ballparks, right? You can say, hey, 50 years ago, a famous player had a home run and they stopped. Right? Other than that, there's some other opportunities you can use. Some people are having solar panels for beacons, so you have to use the battery, right? This is already small, but the majority of this beacon is just because the battery couldn't be smaller. Right? But if you can have solar panel, you don't have to use the battery. You can have a paper, put it on somewhere, and you can put it on. You can make the beacon mobile. You can make the beacon wearable. Right? You can make the beacon as a button. Right? Everybody can advertise. You can make the beacon in bars. So every time you go home, you have to step out and open the garage door. The garage door knows that you're back and it's already open. And even better, you have the beacon in your cars, and the street light will be automatically light up because it knows you're coming. Right? That's an opportunity. And the payload. PDU is about payload data unit. The payload, the information beacon is carrying. That iBeacon carries only 3 data. This 3 pieces of ID. Major ID, minor ID, and the device ID. Actually, in the broadcast packet, in the advertisement packet, you can add more data in it. So I mentioned the physical lab Google. They are adding the URL in the advertisement packet. So the browser will receive the advertisement packet with the URL, and the browser will automatically open that URL. Questions, comments? Flash. Mesh network is to connect to different nodes, ad hoc networking, ad hoc mobile networking. In order to implement mesh, you have to have several features. One is discoverability, because each and every node will have its own services. Hey, I want someone with a printing service. How can I know in the mesh network who has that service? I should have a mechanism, a distributed mechanism, to find out who has that service, the service discoverability. Right? There are several solutions. So Apple's using multicast, the multicast DNS to find out who's available. The second one is packet routing. Say from a distributed DNS, I know there's a node in my mesh network who has the printing service, but that node is beyond my reach, like it's over 100, 150 meters. Right? I need some other node's help to forward this packet to it. Right? There's an app called AirChat. Anyone heard of that? AirChat? Yeah, it's getting very popular. It's they call it off-rate IM. This is messaging. It doesn't require, they use mesh network, ad hoc mesh network, for the instant messaging, the IM application, without the support of carrier. It doesn't use data plan. It only uses Bluetooth, Wi-Fi direct. This AirChat is actually based on an important feature from iOS, multi-tier connectivity. A very cool feature. Spend some time on this. This is the future of wireless communication.
So FireChat uses somebody else's carrier?
No. So if you and I, we can connect. You have Bluetooth enabled on your phone. I have Bluetooth enabled on my phone. We can talk over Bluetooth. And you and him, both of you have Wi-Fi direct. You can talk to Wi-Fi direct. This is cross-transmit. So we can have different physical layers. We talk over Bluetooth. You and him can talk over Wi-Fi, and he can talk over to somebody else over Wi-Fi direct. Right? Using different transmit to form a mesh network. That's part of it. Yeah.
People who don't know, it might be useful to say that this was created for situations like concerts where you have a high density of people that want to interconnect with low availability of cellular network.
Or Burning Man. There you go. Or disasters, earthquake. Right? The carrier network is not available. So mesh. Tracking and positioning. So this device is called CE-SCV. It's part of its name is also called CE-SCV. It's a Bluetooth finder. Or, I have the app and stuff. I cannot show it to you. So it's you can put it in your wallet or your dog, or you can put it on your cell phone or car key. And you open the phone and see where is it. Right? Well, the UI is very fancy. It shows you a radar and where it is. And you can make it beep. It's normally using Bluetooth energy. Because that once the battery can last for like from 12 months to like 18 months. That's a good part of it. So this is we call it proximity application. Right? It's using a term we call it RSI, receive signal strength index, RSSI. And some people are using Bluetooth for indoor positioning because you get some more clear for indoor scenarios. You want to use multiple Bluetooth node, triangulate and calculate your position. This one is called stick and fly. But speaking of RSSI, another frequently asked question would be how accurate is RSSI? RSSI could be used for ranging, but could not be used for, or it's not accurate enough for positioning. You can't, the device cannot give you the value of your location, but it can let you know if you are in the range or out of the range. Right? The RSSI, we always joke about that. If you and this device, there's a big eye between you and this device, the RSSI is almost half. Right? So it's not accurate enough. You put the phone in your pocket or you hold the phone here, the RSSI over there is quite different. So you can't use RSSI. But we have a working group working on having multiple antennas on one device, which can improve the RSS accuracy.
Talk about profiles. We have covered this part. So
connectivity is just the first step of IoT, the connected device. The next step will be the interoperability, the data interoperability. Right? I can connect to it. I can connect to the phone. I can turn on the light bulb. I can turn off my. I can turn on my coffee mug. That's not the goal. The goal is, like I said, use your smartphone to talk to your person. They can exchange data, right? That they can have, they can understand each other without or human interaction, right? So we're working on this now. We're defining profiles standard to standardize data format when we exchange data.
So different devices, different applications could understand each other. Where to start?
Say, hey, I talk about a lot of good things about Smart. I want to try it. Where to start? You can run some data kit or Arduino board with Bluetooth Shield, and you can try some OS. There's a lot of OS. There's
I do have a connector on my iOS device. I have an app that I can scan over in my range. I can know how many Bluetooth devices are available in this room. Right? I can try to pair it.
I always have, sometimes in my stream, I have a little hack stuff. I have a device here, and whoever can hack into my device and put their name in it and broadcast it, I'll give them advice. Arduino, Black, Raspberry Pi, they all have very good support. Go to our website, developer.bluetooth.com, check out our course stacks. And I highly recommend this if you want to be not only understand the technology, also add more impact on the technology. Join our working groups. Here's my email address. You can drop me an email. egao@bluetooth.com. Questions, comments? Go ahead.
For hardware, do you think there are more memory requirements? Can we use the same BLE chips and modules for Bluetooth 4.1 as for 4.0?
The question was, do I need more memory for 4.1 than 4.0?
Yes.
I don't think so. It depends. This is a implementation specific question. You should ask question should be more like, what about Broadcom stack or Android stack? Does their component stack have bigger footprint than the whole one? I don't know. But I don't think there will be a significant increase in terms of footprint.
Roughly how many people on an airplane can be listening to Bluetooth headphones before the sound quality is compromised?
Right. The question is about in one area, again, the personal area network, well, we have, let me put it this way. The sound quality is more, Bluetooth audio application is more on Bluetooth classic, right? So classic has 20 different channels, right? In the 2.4 gigahertz open band, and they have an algorithm to hop between or hop on those 20 different channels. If I see someone's using the channel, I'll hop to a different one, right? So it shouldn't be a dramatic, loss of quality for audio, but Bluetooth, Wi-Fi, and some other technology are all using the same band, 2.4 gigahertz. Right? It is possible. I'm not saying we're all practical persons. It is possible that we have hundreds of devices advertising together. It will be hard to advertise. The bandwidth will be reduced. I say that.
So does it mean only 20 people on an airplane?
No. So Bluetooth classic, right, that you have to be paired to, say, you have a music player and headphone. It has to be paired, right? And then using the same channel to talk to each other, right? It is possible that the other person will have the same device, but they pair with their music player, but they will be using the same channel, right? But maybe they have collision over it. That will reduce the sound quality, and they can still hear it.
So is it correct that the
between 4.1 and 4.0?
My understanding was that 4 versions double channel
No, the bandwidth, the classic still has better bandwidth than the low energy one.
I'm not talking about data.
Right.
I'm talking about the channeling.
Oh, the channel, yes, that's correct, yes. The low energy has 40 channels, yes. Yeah, so the collision is, the chances of collision is small, not small. Double the channels.
So you mentioned they were doing some sort of frequency modeling, which type of scheme were they using?
It's adaptive, it's the adaptive frequency modeling.
I talked to apps engineer at one of the companies that we see. It seems like there's many different types of mesh protocols. Is there going to be a standard?
The question is, different companies, they have different solutions for meshes, and there can be a standard. Yes, we're working on we have a very, we have a big working group working on mesh. So, February is one networking, we'll see what they're working on. Hopefully in a few months, we'll have something available in terms of, but on the other hand, will there be a standard for the entire scenario? I don't think so. Even for when you say it's a smart home, will there be one standard or one technology that's multiple technologies? Wi-Fi, ZigBee, Bluetooth will all be there.
ITF is defined out.
That's true. ITF is working on that as well. Yeah.
Is there any commonality between ZigBee and Bluetooth?
Both are low energy.
No, that's why it's like you use the same combination.
No. Radio-wise, no. They only share the same bandwidth 2.4. No, Bluetooth doesn't use that. Bluetooth doesn't use it. ZigBee, Thread, everything. Bluetooth is different. Yeah, go ahead.
In the new initiative from Google for the Thread, should be on that safety issue in the beginning? What about the security that Bluetooth when you all?
I'm not sure I understand the question.
Thread. Is that thread, right? Yeah, the thread.
Yeah.
So the thread also another similar
Correct.
layer of
They still use AOT buckets.
Right, yeah.
It's based on AOT buckets.
It's based on that. No.
So
It's
more
not brand new.
more close to the
GD.
ZigBee side.
Except
It's based on ZigBee. Thread is more ZigBee. Yeah. It's more on the application side.
GD is only defined by. There is no mesh defined. It's only defined G, that's for one, only one. But you can have a mesh layer.
What is the IPR
ITL.
Intellectual property?
Okay. No, we don't. You don't have to pay anything for the IP. So it's royalty free. Bluetooth itself is royalty free. We do have a program for certification. Yeah.
So Ericsson doesn't collect it all.
No. Yeah.
Any projections for the cost of adding an interface to the device, 5 years down the road? Is it going to drop?
Yeah, that's a good question. So this device and where's my pin?
So this device sells for, I think it's $24.99 or $25. I think the chip itself is something now, the BOM, I'd say, is below $5. And we are seeing this will be, in 4 years, will be below $1 for the BOM. We have one manufacturers. We have one of them, to add this to your device. So there's several parts in your cost, right? The BOM cost, I would say BOM cost would be the least significant. You need to pay for, so there are compilers. It's a good amount of cost for compilers. There are also open source compilers. There are also, so there's a company called Vincent. They are one of the major players in Bluetooth and wireless connectivity. They work with ARM to have their network and their product compatible with a platform called NAT. And that is a super cool development environment. It's basically you use browser. Browser is your compiler. Most of the compiling is on top. You just connect the device with USB to your computer, and then you type in the URL, and that as you send that org, and you start working on debugging the code, and then once it's compiled, you can flash the binary, the hex file, to the device itself. So that is a very good feature, and it's saving a lot of compiler. Yeah, that's IEEE as a platform by ARM.
this iPhone that supported Bluetooth Low Energy?
4S. iPhone 4S.
How long ago was that?
Oh, I don't know. It's one of the quick last year.
2011.
Yeah, this is hard. All right, so thanks everyone for coming.
Thank you very much.
Thank you.
So a little bit, it's a 10th anniversary mark from
Oh, nice.
some collectible something.
Okay, thank you.